Well, it looks like we have been able to separate some pigments here, and this first lane is very, very faint, so I am definitely going to use more than one application on my next TLC plates. Here at the center, we had 4 applications, so we see the green at the bottom, the nice grayish dot up above, and then we have a yellow pigment that has run almost all the way to the top of the solvent front. The nice thing about this is that we do see that the 4 applications and the 7 applications are pretty similar to each other, so I think I'll be able to get away with just doing 4 applications on the next TLC plates. So what I'll do next is set up the origin line and start spotting my next TLC plates. Alright students, so what I have done here for the TLC plates is I have created the origin line, and I put down 4 applications onto each TLC plate. I also labeled the top of the TLC plate with the solvent that this plate will be going into. So we have a plate that will be going into pure toluene. This is 7 parts toluene and 3 parts acetone. Here we have a plate that will go into pure hexanes and one that will go into pure acetate. I'm going to take these 2 to fume hood and place them in their respective containers. Again, I'll mention in what order we are going. So this blue labeled one is pure toluene inside of the jar as our solvent. And hopefully you can see we got a yellow spot moving upwards and a green spot staying very close to the origin line. And our next solution here, it is the one that is 7 parts toluene and 3 parts acetone. Looks like we're getting some separating and different colors occurring in the spots. Okay, the next tag here, this one is hexanes. So hexanes is a very non-polar solvent, but we do see something occurring there. And last but not least, here in the pink, we have pure acetone. Alright students, so now that we have put all of our plates in our TLC jars and removed them, we're going to begin calculating the RF values for our TLC plates. To calculate the RF values, we're going to do this for every spot. So we're going to calculate an RF by calculating the distance of the spot and the distance of the solvent. Okay, measurements will happen 2 different ways. For spots, we will do the measurement from the origin line to the spot itself. And for the solvent, we're going to measure from the origin line to the solvent front, which I have marked on the TLC plates with pencil. So for an example, we're going to work on the 9:1 toluene acetone plate, and in that we see 3 different spots. So I'll have Lee bring it back to the TLC plate here, and let's take a look at what are those 3 different spots. Okay, so at the very top we have the yellow spot, and then as we pan downwards we see that we have a spot that I circled, and that has faded over time. And then we do see that grayish spot that is hovering above the green. I will not calculate the actual, the spot that did not move. If it remains on the origin line, it should not be counted because obviously its RF would be 0 since it did not move. So let's go ahead and take some calculations here. For this plate, the solvent has moved a total distance of 5.1 centimeters. So for spot number 1, 2, and 3, the distance for the solvent is going to be the same. And for this first spot, which is the yellow one, it moved almost to the line itself, but I'm going to be very careful here, and we've got a distance of 4.9 centimeters. So I'm measuring to the bottom of the spot. Okay, so we're going to take the value 4.9 centimeters. We will divide by the solvent distance, which is 5.1 centimeter. And notice that I'm always going to get a fraction. The fraction value will always be less than 1. Okay, so I have a distance for spot number 2 of 0.17 or 0.7 centimeters. Once you calculate the solvent front distance, then it should be the same for all spots on your plate. And the very last one, only 1 millimeter, which is 0.1 of a centimeter. One last thing to note here. Notice that I am doing my distances using the same unit. Whenever RF values are calculated, you must use the same unit. The value you will obtain will be a unitless ratio. Okay, so what we are looking at here, students, are the TLC plates for the rest of the solvents that we tested. And we have a ruler set up next to each one so that you will be able to calculate the RF values for each spot on each TLC plate. Please make sure to keep track of the spots by creating a table for each of your TLC plates. So it looks like for the plate that is labeled 7 to 3, you will have many spots to determine the RF value for. We've got a yellow spot at the top, a gray spot right underneath. There appears to be 2 different green spots, a yellow one in the middle, and nothing down towards the origin line. And then for toluene here, looks like we've got a yellow spot that ran towards the top, and then a slight movement of gray right above the green at the origin line. Okay, now just to ensure that you remind yourself how to calculate that RF value, let's go back to the RF calculation. So again, it is the distance traveled by the spot divided by the distance traveled by the solvent. So you will need to calculate the distance of the solvent for each of your TLC plates and calculate an RF value for each spot that you see on that TLC plate. All right, students, so just to help you guys out with some identifying of the pigments, I made a list here of the typical pigment colors that you will see. Beta carotenes are usually the orange-yellow spot that you find on your TLC plate. Pheophytins are a greenish-gray color. Xanthophylls have a yellow color. Sometimes they're very faded yellow color. And the chlorophylls are green. Now, remember that there are 2 different types of chlorophyll in this pigment. There's chlorophyll A and chlorophyll B. If you do manage to see both types of chlorophyll, you will have to use the structures of the chlorophylls to determine which one is the more polar of the 2. All right, this has been separation of spinach pigments by TLC.